Hello, this video lesson is about how to calculate the measures of central tendency, mean, median, and mode, if you have grouped data. So what is group data? Great question. I'll show you. Data is called grouped when it's presented in a compact table, also called a frequency table, rather than being listed out. Why would you do that? Well, if you have a lot of data, instead of having a list that has 27 and 33 and 12 things, you might group your table this way to be more compact. So this is just a made up table that shows the age of students and the frequency of that age. So what does this data table mean? It means that there are 27 people who are 14 years old. There are 33 people who are 15 years old, and there are 12 people who are 16 years old. So that's the distribution of this data. So instead of listing 14, 14, 14, 14, 14, 27 times, comma, 15, 15, 15, 15, 15, 33 times, and then a whole bunch of 16s, 12 of them, it would be much easier and more compact to list the data this way. So that's one type of group data. The other one is a group where this age is not a single age, it's an interval. So if I was keeping track of how many people are between the ages of 10 and 12, 12 being excluded, so that's up till like your 12th birthday, but not including the actual day that you turn 12, there are 25 people in that age category. There are 67 in this age category from 12 to 14, 85 in here, and 31 in here. So the difference is that in this setup here, each category is a single value, and in this one, it's an interval or range of data is each actual category that you're talking about. So how do you find the measures of central tendency in these cases? Well, for the mean, remember that the mean is adding up all of the values and dividing by how many you have. So here, I know that I have 27 14-year-olds. I have 33 15-year-olds, and I have 12 16-year-olds. So rather than add up 14 plus 14 plus 14 plus 14 plus 14 plus 14 27 times, there's a quicker way that I can do that. I can multiply the value times the frequency, and then multiply this value times the frequency and this one, and then add them up. And the total number of numbers in my list would be the total frequency. That tells me how many of each one there is. So the formula that I can use is that it's the sum of the value times frequency, and it's divided by the total frequency. So here, if I found those values as a side calculation, I could put it all into my formula in one shot. My mean here would be the sum of these values, the value times the frequency, the 14 age times the frequency of that age, and 15 the age times the frequency of that age. That sum divided by the total frequency. And I would say, I would actually probably put approximately equal to if it's a non-terminating decimal. So that's my approximate age. Does that make sense? Is that reasonable? Well, the ages are between 14 and 16. There are fewer 16-year-olds than there are 14-year-olds, and there's a bunch of 15-year-olds. So yeah, it seems reasonable that the mean would be around 15 and maybe slightly lower than 15. It seems like a reasonable answer. And if I had an interval of data, I would do the exact same thing, but how do I know what value to use in here? Should I use the 10? Should I use the 12? The answer is that I will take exactly halfway between the two endpoints of each category. So halfway between 10 and 12, that's 11. Basically, if I was looking to calculate that, I would take the mean of the two endpoints. That middle point or mean is 13, 15, and 17, and I would multiply those by the frequency of each category. Again, I don't have to do this as a side calculation. I could have put it directly into my answer. I could have just written mean equals, and then 11 times 25 plus 13 times 67 plus, and divided by the total frequency. And again, I should probably have an approximately equals 14.17. Is that reasonable? Well, let's take a look at the data. Our ages range from 10 to 18. So that's somewhere in between. That part's reasonable. And most of the data is clustered around this 12 to 16. And again, we're inside that. So that seems about reasonable as well. ROIT, the median. Remember that the median is the middle value. So instead of listing out 100 numbers or 200 numbers, there's an easier way to find where the median is. So remember that once the data is ordered, we're looking for our middle value. It's the actual middle number. But there's a connection between how many data points there are and what is the position of the median. So this is the formula that shortcuts where the median is. If you take the total frequency, add 1 and divide by 2. Why are you adding 1? Why are you dividing by 2? Well, it's kind of taking the halfway point, but it corrects for the fact that if you had, let's say, 5 numbers, which is an odd number, if I just did 5 divided by 2, 5 divided by 2 is 2.5. It doesn't tell me that the actual middle number is the third. But if I did 5 plus 1 divided by 2, that tells me 3, and that is the actual middle number. Because I don't want to cut this into 2 equal parts of 2.5 and 2.5. I want to know where the middle number is by having an equal number on both sides and then taking a number. So similarly, if I had an even number of numbers, let's say 4, if I just divided that by 2, 4 divided by 2 is 2, but if I want to know where the middle number is, it should be the 2.5th number. It should be between the second and the third. So adding 1 and dividing by 2 corrects for that. It's always going to be that, no matter how many things you have in your frequency table. So if I did that here, if I found the total frequency, plus 1 divided by 2, I end up with this number. This is not the median, but it tells me where to find the median. It means that my median is going to be between the 36th and the 37th data points. So now I have to figure out where those are. And the frequency in my table helps me to do that. Because the fact that there are 27 numbers here and that 14 is the lowest age means that if I were to list these, this would be my first data point and my second and my third and my fourth up till the 27th, because there are 27 of them. And that means that this one will be my 28th up until the 27 plus 33rd, up until the 60th number. And that means that my 36th number is in here and my 37th number is in here. Both the 36th and the 37th numbers are 15. So, I mean, this is kind of irrelevant because I know that both of my 36th and 37th are in that category, and so 15 is my median, it's the middle number. And same for something like this. If I wanted to know where my middle number is, I would take the total frequency plus 1 divided by 2. That tells me where to find my median. I'm looking for the 104th number. And then I'll figure out where that is. This one's going to go up till 91. This one's going to go up to 176. So my 104th number is going to be in this category, which means that, again, my median isn't 104, nor is it 85. This is the actual data. So my median category is 14 to 16. That's where the middle value of this data is. And finally, mode, nice to best for last, easy one. That's simply the data or datum with the highest frequency. So I have to look at the frequency, but my actual answer is going to be an age. This is a data table about age. But in this case, the fact that there are 33 15-year-olds, that's higher than these other frequencies, that makes this the most frequent number. That's the mode. Mode is 15. In this case, the highest frequency is in this group. The mode, or sometimes called the modal class or modal category, is 14 to 16. It's the group that has the highest frequency. That is that.